is doing this plumbing work, and three experts will working on the three different kind of works at the same time. Three experts is working on a three different kind of works. Three means it is multiple, and these three works also multiple. Multiple instructions and multiple data sets as a best example here. That is called here you want to perform different kind of applications over in the single system. As nowadays we are using laptops in a high-end configuration laptops, which is working on a we can run a C programming or Python programming parallelly. Doing the Python program still it is under execution. You can able to run a video in your system and another window. While playing video also, you can have to prepare your PDF. You can read a PDF while you open a PDF and you read it. So there are three activities we are doing in the same time. A program which is already successfully successfully executed me without errors. Then we have given in a running condition. Run, you click a button run on a Python program. For example, let's say that program will take 1 hour of time to run. So some programs will 2 days also will take. So let's say it will take 1 hour of time to take completion of that running process. While it is going on that, meanwhile you have opened one window of video playing, and also you have opened one more document as you want to see one document also PDF also opened. So these three activities are simultaneously doing, and backgroundly it is not that only one system, one processor can do it. So you as we discussed, no core, multi-core. So in the multi-core, different kind of processors are there. Those different kind of processors, or we can say process 1, process 2, will executing the instruction 1, instruction 2, instruction 3. Instruction 1 is playing video, instruction 2 is running a Python program, instruction 3 is running opening a PDF, right? Such that n number of actions we are doing for different data sets, for different kind of data. Here while writing a program for Python program, then we need some input data. While video playing, the input is not required, the purpose is different. The PDF opening input is not required, the purpose is different. So there are different kind of purpose, different instructions running and executing independently. That is multiple instructions and multiple data uh, system. So here with this, these are the four types of parallel systems. First one is SISD, single instruction, single data system. There are only single processor, no multiple processors. Processor is only one and data also only one. So there is only one person, he has to do everything. So definitely has to do that in a sequential manner. One time is capable to run only one program. Data తీసుకోవాలి, ఆ instructions follow కావాలి, and this instructions and data will be considered and do some processing. This doing some processing is done by the processor. That is only one processor in SISD. Next one is SIMD, single instruction multiple data systems. In SIMD, I told you an example. Well, any faculty has given an assignment that do this problem with the different data values. No two students will have the same data values. So there is an expression, there is a formula to do that, and apply this algorithm or considering a problem statement, apply different kind of algorithm or method by this, but same formula you have to use. The same formula is nothing but processing is the same, but you work on the different data. ఇందాక చెప్పిన కదా, సేమ్ పైథాన్ ప్రోగ్రామ్ రన్ చేయాలి, addition of two numbers program, but no student should have same output. But 2 comma 3 input is some other else will give some other value. Like that, every same program can be run on a different data set. Single instruction, multiple data. And next one is multiple instruction, single data. The instructions are multiple instructions. Different kind of programs we have written. C program, Java program, and Python program. All the program aim is to perform addition of matrices, addition of two numbers, right? Finding of GCD only. Addition of two numbers using C, addition of two numbers using Python, using Java, addition of two numbers. But multiple instructions, what is the data? Data is common data, any two numbers. If it is 2 comma 3 is given to the first program, addition of 2 comma 3, it gives the output is 5 as C program. You run a Python program, give the input value is 2 comma 3 only, same data. it also produces an output 5. And you run a Java program which is indicated as the addition of two numbers, the input data is 2 comma 3. For all these instructions, all these programs, input is 2 comma 3 only, output is 5 only. But we are running on a different processes and a different instructions, C, Python, Java. That is multiple instruction, MISD, multiple instruction, single data. Whereas next one, fourth one, multiple instructions and both multiple data also. Multiple instructions, multiple data. Multiple instructions, multiple data is nothing but for every program in is individual. For example, if I said instructions 1, 2, 3, 4 and so on n for n number of programs, program 1, 2, 3, 4 contain different purpose. Addition of matrices, addition of two integer numbers, right? GCD of a two numbers and factorial of a given number. So there are four programs I've written for the each program is individually, independently. Whether you use C or programming language, whatever it is. But their purpose is different. If the purpose is different and also input data also different. The program 1 for the data input data 1 is given. But this program 1 and data input is working on the one machine, one processor, sorry, not machine, processor is called as one processor 1. Same like, I mean, same like here, one more processor, processor 2 working for the other program GCD of two numbers, for that data set is separate. And other program it is running on a Java programming or something else. A program is only same language. For example, it is factorial of n number. For data set input is different. There are different kind of input data sets on working on the different kind of instructions. On working on the different kind of instructions. Multiple instructions, multiple data. Most of the computers are preferred this type of systems. So here write down MISD, make a one point here. The system can handle many instructions at the same time and each working on a different set. Write down. This MISD system can handle many instructions. MISD is working, can handle many instructions at the same time, can handle many instructions at the same time, each working on different set of data, each working on each working on different sets of data. Next point, MIMD systems are very powerful, is very powerful because they can perform multiple complex operation. MIMD systems are more powerful because they can perform because they can perform multiple complex operations. They perform multiple complex operations. MIMD is broadly categorized into MIMD broadly categorized into two categories. The first one is shared memory systems and second one distributed memory system. Now we're going to discuss about those two. The first one shared memory system and second distributed memory system. And we know already distributed system, how distributed system is working. And this MIMD is used in supercomputers. I told you, no, this MIMD system is more powerful. It processes the data very fastly. Then we can say it is a, this technique will be used in a supercomputers. So it will be used in supercomputers or advanced multi-core processor that requires lot of Like in a octa-core, there are 8 cores of processors. 8 cores are there. 8 cores will the same memory space, which is same SSD, which is installed, which is connected to your device. Since each processor has its own memory, easier to expand as more processors and added also very easy. So whenever a number of processors are increased and the sharing global system memory, this can be shareable for the, if you add not only n number of processors, that n number of processors, this global shared memory can be served. It serves for the not only limited number of processors, n number of processors, the global memory can be able to serve, can able to accommodate, can able to load the data of the different kind of processors. It avoids memory traffic jams because which is even though which is shared and the memory traffic jam is avoided because it quickly the performance or execution speed is very fast and harder to program because processor must communicate by sending a messages. But the disadvantage or there is a problem encountered that whenever you wish to communicate with the processor 1 or processor 2, then we have to write a logic that communicating on that core, multi-core, octa-core, communicating or writing, establishing connection between the processors is little bit complex for establishing a connection, but we can do that. So note down this diagram for the shared memory MIMD machines. But either shared memory MIMD, just you remember that there is a common memory system globally connected for all the processors. Globally connected for the individual processors of in a single system. ఒకే సిస్టంలో ప్రాసెసర్స్ ఎక్కువ ఉంటాయి. సో ప్రాసెసర్ అంటే నీ దాంట్లోనే ప్రాసెసర్ 1, ప్రాసెసర్ 2, ప్రాసెసర్ 3. ఇట్ ఈస్ నాట్ లైక్ సిస్టమ్. అందుకే సేమ్ జావా ప్రోగ్రామ్ రన్ చేయొచ్చు మన సిస్టంలోనే ప్యారలల్గా పైథాన్ రన్ చేయొచ్చు, ప్యారలల్గా సి ప్రోగ్రామ్. సి ఓపెన్ ఏ సి ఎడిటర్, రైట్ ఏ సి ప్రోగ్రామ్ అండ్ రన్ ఇట్. ఓపెన్ పైథాన్ ఎడిటర్, run a program, and open notepad and write a Java program, you can run it. Three individually can run at the same time in same PC, same laptop. That is happening because of that MIMD system is there. There are multiple instructions can be run by the multiple processors. Distributed, next category of MIMD, distributed memory systems. This distributed memory system, the communication through communication network, every processor has its own memory. Each processor has its own memory. So in this distributed company or distributed computing system, whereas previously there are NM process 1, process 2, process 3, there is a common memory. But in the distributed it's not like that. Process 1 has its own memory, process 2 has its own memory, process 3 has its own memory. And as and when is required, process 2 required more amount of memory and it is requesting other process 1, 3, 4, 5 and so on, which is available, then their own process memory can be shared to the other process. Everyone you have your own bag. Everyone you have your own bag to store your books and pens and whatever it is belongs. All the belongings of you can be stored in your own personal bag. Sometimes, and your bag is full, and your belongings or notebooks are more, which is not able to fit into your bag. Then, in the same way, like you, other people also have their own bags, their own capacity to carry notebooks. Then you have to ask the other person, please keep these two notebooks in your bag as my bag is already full. We are sharing the resource. The resource here is capacity to hold bag. బ్యాగ్లో స్పేస్ లేదు కాబట్టి వేరే అతనికి బ్యాగ్ ఉంది. ఇండివిజువల్లీ దేర్ ఆర్ ఓన్ బ్యాగ్స్ అండ్ సమ్ టైమ్స్ యూ హ్యావ్ లగేజ్ ఇస్ మోర్ దెన్ సమ్ ఆఫ్ కీప్ ఇన్ టు ద అదర్ పీపుల్ బ్యాగ్. సో హీ ఈస్ షేరింగ్ ద రిసోర్స్ విచ్ ఈస్ హ్యావింగ్ హిమ్సెల్ఫ్ టు ది అదర్స్. ద సేమ్ వే ఈచ్ ప్రాసెసర్, దిస్ ఈస్ client 3 will have a web server. Right, client 1 will have its own CPU and own data set. And client 2 also email server. Like client N as a printer server. Different users will have a different kind of storage devices. As and when the storage device is client 3 of web server is already filled and still he want to store the data. He could not accommodate at the web server. Once he could not accommodate the web server which is already filled, he is requesting other users by through communication network. By communication network, he is requesting that please I need so 1 GB of data from your end. So he is sharing through the network. I told you no independent. Four members are working for the same problem by connecting itself. Distributed. మీరు ఫోర్ మెంబర్స్ గ్రూప్ కాల్ చేసుకొని యూనిట్ వన్ one fellow is perfect, unit 2 other fellow, unit 3 other fellow, unit 4 other fellow. So whenever unit 1 is perfect and he is asking to other person, please tell me unit 2. So in the group itself we are sharing the knowledge. Same like distributed system, here distributed memory can also be shareable and easier to expand as more processors are added. So here the processors 1, 2, 3, 4 and n number of processors. The processor can be added. Addition of the processor is easy because every processor has its own memory and not like it is a common memory. It avoids memory traffic jams. So here their own memory, most of the cases memory traffic jam radu because we are not accessing common memory. It is accessing your own memory mostly. Only sometimes we are requesting others. So during that time, most of the cases, that's what most of the case memory construction, that is congestion, cannot be possible. Harder to program because processor must communicate by sending messages. So here also it is little complex programs you have to write to communicate one individual system or individual client with other client by using the communication network. So there is a program you should run in a system to communicate with the other system. That's what it is. Nowadays, no need to write a program. We have a inbuilt software is that VPN. Can be just you install VPN in a multiple systems. We can communicate with the multiple systems, each one. VPN ఉంటే సరిపోతుంది. రిమోట్ సిస్టమ్ ఎక్కడున్నా సరే we can communicate. అక్కడ ఉన్న రిసోర్స్ అన్ని మనం యూజ్ చేసుకోవచ్చు. This is the structure of distributed memory of MIMD machines. Normally MIMD machines ante multiple processes, multiple data set. Processor, right? Processing its own data set. Processor 2 own data set is processing. As distributed system, every processor will have its own memory. See, for the processor 1 local memory, for processor 2 local memory and so on, processor N also will have its own local memory. So in this is the structure of the distributed MIMD system where each processor has its own memory to process the individual data set. For the processor 1, for this processor 1, data set is separate. So note down this distributed MIMD system. Diagram just you note down. Note on the same diagram, on top of that processors, and each processor is associated with the local memory. Each processor is associated with the memory. Such that different set of processors. So ఈ box చూడండి. This dotted line shows that one processor with the attached local memory, such that processor 2, processor 3 and so on. And each processor will be sharing the resource as and when requested. So that it will be sharing shows that this arrow. To share the resource of one process to another process, we need a communication. Communication జరగాలి. But communication can be taken place by using IPC. Paina arrow paina IPC. What is IPC? We'll discuss. On top of this blue arrow, there is a name called as IPC channel. IPC channel will establish a communication between the distributed systems. When we are going to discuss in the distributed systems, I told you that already there are four independent systems are communicating with each other through internet. The communication can be established in the through the net only. But how it is the communication can be takes place? There is a separate mechanism, separate technique is called IPC. Over. So note down a few points about distributed computing. This already done. Sorry. Now we'll discuss about these two techniques. MIMD can be categorized into two ways. One is shared memory MIMD system and distributed memory MIM system. In MIMD, shared memory, right on the first point, the shared memory MIMD architecture is easier to program but less tolerant to failure. There may be a chance of failure occurs in the shared memory MIMD systems. ఏదో పాయింట్ వస్తుంది కట్ అవుతుంది ఇక్కడ అంతేనా? Right on the first point, the shared memory MIMD architecture is easier to program. So the technique you can implement it is easy. But if you use that shared memory distributed shared memory MIMD, and it may be a chance of failure, but it less tolerant to failure and harder to extend with the with respect to the distributed memory MIMD. So the first comparison between these two is shared memory MIMD is very easy to implement as compared to the distributed. Because distributed computing MIMD can be established, the communication can take place by separate method called as IPC. That IPC is separate mechanism again. So we need to learn about IPC. Where in the shared memory MIMD, separate mechanism and no need of any extra knowledge, we can simply write a sample code to establish a connection between the common memory to the processors. That is easy. But what happens that if any processor may lose the data, that fault tolerance cannot be predicted. There may be a chance of getting fault tolerance. And second point, failure in a shared memory MIMD affects the entire system. So in the shared memory, this is a common place for all this. If anything is happened for this table, then everything will get suffer because all people are sharing the same, right? If this is damaged, then it is affect to the not only one person, to all the members. In the same way, processor 1, 2, 3, 4 and n number of processors are sharing in the common memory. Diagram on the process 1, so the shared memory is a common location. Process 2 also same pointing to the shared memory location. If this memory location get corrupted or get damaged due to the various reasons or any physical damage or logically or technically something went wrong, then the data will be lost. This loss of data can impact on this not only one process, all the entire process. But every processor as depends upon this common memory only. Once data is corrupted, data may be lost, then memory may be damaged. It will affect not for the single processor, it affects all the computers, all the processors. Whereas in the distributed, you have your own memory space. You have your own bag. Has your own bag. Everyone will have their own bag. If any one bag is damaged, it will affect to that person only. No effect for the other persons. In the same way, processor 1, 2, 3, 4 has its own memory capacity. And if anything is happened for the process X, it doesn't affect the remaining process. Unless the process X memory is shared to the other process. But there may be a chance of affecting the other process when the process X is shared that own memory to the other persons. The situation may arise very less amount of choice. Very less case that possibility is there, but most of the cases it will not affect the other processes when it is memory is damaged. Moreover, shared memory MIMD architecture is less likely to scalable because the addition of more processes leads to a more contention, right? Here the number of process increased in the shared memory. If the number of chairs is increased for with respect to this chair only, then it is very difficult to sit in the common table not more than 5 or 6 members. And we are accommodated for the same table at 10 members. We ask them to sit 10 members and use this table for our writing only. And 10 members, the sharing of this table is difficult. For 5 or 6 it is okay, 7 a little bit okay. But I told you that use this table for writing. Everybody use this table for writing only. By using of 10 members, sharing of 10 members is very difficult because this is the commonplace. Whereas in the distributed memory MIMD, everyone will have their own, for example, everyone will have own table. Then adding one more processor, adding one more chair and one more table for the next user, it is also no problem. 6 members have set their 6 own tables. Then I can add 7th member, 8th member, 9th member, no problem because the 7, 8 members are also having their own tables. Then it will not disturb to the others. So that is a problem in a shared memory, whereas in the distributed, such a problem may not be encountered. So that's what, moreover, shared memory MIMD architecture, third point, are less likely to scalable. Scalable, we cannot increase the number of process by using the same memory. If the number of common users are increased for the common place, a memory 1 terabyte can be accommodated, for example, 10 members. If 20, 30, 40, 100 members, then 1 terabyte is divided by 100 members. So each person will use only little bit of amount of space that cannot be useful for to run any of the program. If 1 terabyte is accommodated for only 5 members, then enough sufficient space is allocated for each user. They can run some good number of applications by using the allotted space. Right? Okay, chocolate ఇచ్చి 2 members ఇన్మంటే okay. 3 అన్నా we will not accept usually. డైరీ మిల్క్ చాక్లెట్ తీసుకొచ్చి 2 members అంటేనే మీరు ఫీల్ అవుతారు కదా. 3 లిటిల్ అడ్జస్ట్ 4 ఒక చాక్లెట్ ఇచ్చి 10 మంది తిన్నాం అనుకో, నీ చాక్లెట్ వద్దని పక్కన మొహం కొడతాం అంతే కదా. That is the effect that, so if it is sharing that 10 members as a one chocolate, it is there is no feeling, chocolate is a feeling ఉండదు ఇంకా. సో అందుకోసం so we'll reject it. In the same way, the same common shared memory cannot be extended number of, it will not be scalable for the large amount of processes. Whereas is distributed, it will be communicating through the network only. If 5 members, next 6 member, 8 member, 9 member, 10 members can be accommodated. So this situation does not happen in the case of distributed memory. As a result, distributed memory MIMD architecture are most popular today. Because of that reason, we are following in MIMD architecture, we are following distributed MIMD architecture, not shared memory architecture. Right? See here, this is a layer view of distributed system. As we know that distributed system will have a separate processor, separate infrastructure of every system. This is hardware and operating system, middleware and the applications. These applications, every application will be used by using this middleware and operating system can be communicated with the hardware. For example, hardware components in the your system, printer ఉందనుకోండి మనం ప్రింటర్తో కమ్యూనికేట్ అవ్వాలి. దెర్ ఈస్ హార్డ్వేర్ కాంపోనెంట్, ప్రింటర్ ఈస్ దేర్ ఫిజికలీ. If you want to communicate with the printer, we don't want to write any command. ఒక మౌస్ ఉంటే సరిపోతుంది. Printer should be installed in your system and there is control P button. Print పైన క్లిక్ చేస్తే సరిపోతుంది. The communication can be established between the printer. And a hardware device, so we are establishing a connection. If that user friendly one click button లేదనుకోండి, then you go to the console. In the console at command prompt, identify the printer and write the command to open a printer and get the command for giving the printer of which document where it is available. That is the location of the file. So then the complex and that is system programming we can say. అవన్నీ లేకుండా ఏం చేస్తున్నాం, మనకి ఎట్లా కమ్యూనికేషన్ అవుతుంది, మనం క్లిక్ చేస్తే ప్రింటర్ ఎట్లా ఆన్ అయిపోయింది, అవసరం లేదు మనకి. ప్రింటర్ కేబుల్ పెట్టాలి, డబుల్ క్లిక్ చేయాలి, ప్రింట్ అనాలి, ప్రింటర్ సెలెక్ట్ చేసుకోవాలి, ప్రింట్ అని చెప్పాలి, అయిపోయింది. That is user friendly nowadays. So here the architecture represents this hardware noise, right? It is a printer, for example, where the topmost we the users, where the users can communicate with this hardware, but by one clicking we can communicate with this hardware. That is going to happen because of in between there is a middleware and operating system. The application is one clicking, mouse clicking, and this circle represents at your place, and middleware and operating system will be, that's what operating system definition itself. Operating system is in a software which enables the services of an hardware component. Normally we can say definition of operating system, interaction between interface between user and the system, interface between user and the hardware component as in a system, operating system as an interface. ఆపరేటింగ్ సిస్టమ్ నువ్వు క్లిక్ చేసినాక సిస్టమ్ రెస్పాండ్ అవుతుంది, ఆపరేటింగ్ సిస్టమ్ ఇన్స్ట్రక్షన్స్ చెప్తుంది, బాబు యూ వాంట్ ప్రింటర్, జస్ట్ వేర్ ఈజ్ ప్రింటర్, జస్ట్ యూ టేక్ దిస్ యాక్షన్, నీకు ప్రింట్ చేయాలని ఒక పని చేయాలని చెప్తుంది. సో దిస్ ఇస్ ద వే ఇట్ ఈస్ వర్కింగ్ ఇన్ ద డిస్ట్రిబ్యూటెడ్ ఎన్విరాన్మెంట్. సో రైట్ డౌన్ దీస్ 1 2 3 4 layers. It is working in such a way that these are the different kind of layers inside of the distributed environment. Note down these four names: hardware, operating system, upon this middleware, on top it is applications. మనం ఎప్పుడు అప్లికేషన్ యూజర్ ఎండ్ సైడే ఉంటాం. ఫోన్పే యాప్ ఓపెన్ చేసి నంబర్ కొట్టగానే ఆయన అకౌంట్లో డబ్బులు పడడం ఏంటి, అకౌంట్ నెంబర్ లేదు, ఏం లేదు, మొబైల్ నెంబర్తో మనీ ట్రాన్సాక్షన్స్. వాట్సాప్లో ఆయన నంబర్ కొట్టేస్తే ఆయనకు మెసేజ్ పోవడం ఏంటి, వాట్సాప్లో రికార్డ్ చేస్తే ఆయన మెసేజ్ అక్కడెక్కడ ఉన్నవానికి వినపడడం ఏంటి. దిస్ ఎవ్రీథింగ్ ఈజ్ హ్యాపెన్ through the internet and internally of respect to the system. That communication can take place with the help of middle layer technologies with the supporting of operating system. That internal process will least bother. అందుకే మనం లాస్ట్ యాప్ యూస్ చేస్తాం, క్లిక్ చేస్తాం, అయిపోతుంది. లోపల ఎట్లా జరుగుతుంది అనేది దట్ విల్ బి ద ఇన్స్ట్రక్షన్స్, దట్ ఈస్ కాల్డ్ అన్ యాప్ డెవలప్మెంట్. అక్కడే దాంట్లోనే కదా యాప్ డెవలప్మెంట్ రాసే ఇన్స్ట్రక్షన్సే అవి. క్లిక్ చేస్తే ఏం జరగాలి, ఏ ఇన్స్ట్రక్షన్స్కి ఎట్లా రియాక్ట్ అవ్వాలి, right? That is general distributed. Now it is architecture of a distributed system in a cloud computing. So there are 3 layers here. First, social networks, scientific computing and enterprise applications, end users normally using. And whereas in the bottom, framework for cloud application development, the last one is virtual hardware, networking, OS images and storages. See here also in the cloud computing environment, how distributed system is working. In the same way, just an assumption that on top of this, that is where the end users and want to communicate with the cloud system, cloud services. The cloud services can be computed with the framework cloud application development is a layer is there. On that layer, the communication can be takes place. Once the communication has been established, then bottom layer, hardware components. నీ దగ్గర ఎక్కడ కూడా ప్రింటర్ ఉండదు బట్ ప్రింటర్ సర్వీస్ యూస్ చేసుకోవాలి నీ దగ్గర ఎక్కడో మెమరీ లేదు నీ సైడ్లో యూ డోంట్ హ్యావ్ ఎనఫ్ స్పేస్ టు లోడ్ యువర్ ఆల్ 4 years ఆఫ్ ఇమేజెస్ 4 years ఆఫ్ యువర్ పిక్స్ ఇన్ మొబైల్ అంత డేటా నీ మొబైల్లో లేదు బట్ డ్రైవ్లో స్టోర్ అయింది డ్రైవ్లో స్టోర్ కావాలంటే అప్లికేషన్ వచ్చే ఫ్రేమ్వర్క్ మిడిల్ లేయర్ అండ్ వర్చువల్లీ హార్డ్వేర్ అండ్ నెట్వర్కింగ్ ఓఎస్ ఇమేజెస్ అండ్ స్టోరేజెస్ సింపుల్ ఎగ్జాంపుల్ నీ ఫోన్లో ఉన్న lakhs of images can be loaded into the drive అవన్నీ నీ మొబైల్లో లోడ్ చేస్తే ఎనఫ్ స్పేస్ సరిపోదు బట్ మనం ఏం చేస్తాం ఓన్లీ వన్ క్లిక్ డ్రైవ్ క్లిక్ చేసుకుంటాం యాక్సెస్ చేస్తాం గూగుల్ ఫోటో అనే ఒక ఐకాన్ ఉంటుంది గూగుల్ ఫొటోస్ ఉంటుందా మొబైల్లో గూగుల్ ఫొటోస్ ఫొటోస్లో గూగుల్ ఫొటోస్ ఒక ఐకాన్ ఉంటుంది అది క్లిక్ చేస్తే ఫొటోస్ అన్నీ మనకు కావాల్సిన అన్నీ చూపిస్తుంటుంది ఇట్ విల్ నాట్ బి డౌన్లోడెడ్ జస్ట్ ఇట్ విల్ షో డౌన్లోడ్ అయితే మళ్ళీ ఏమైనా మెమరీ ఫుల్ అయిపోతుంది ఆ ఒక్క క్లిక్ వల్ల ఎట్లా జరుగుతుంది బికాస్ ఆఫ్ దిస్ మీన్స్ టు layers framework for cloud applications contains middleware technology and with help of operating system అప్పుడప్పుడు గూగుల్ డ్రైవ్ మన డ్రైవ్ కూడా ఫుల్ అయిపోతుందా ఎనీవన్ హ్యావింగ్ ఏ మెయిల్ ఐడి ఫుల్ అయింది ఎప్పుడైనా మెయిల్ ఐడి ఫుల్ వీ విల్ నాట్ రిసీవ్ ఎనీ మెయిల్స్ అండ్ విల్ ఆర్ అనేబుల్ టు సెండ్ మెయిల్ బికాస్ గూగుల్ హెస్ ప్రొవైడెడ్ some free space 25 GB or something 25 GB I think so yes 50 15 not 25 15 GB is free సో మనం వాడేదానికి ఎక్కడ మన మెయిల్స్ ఏం యూస్ చేయము మోస్ట్ ఆఫ్ ద కేసెస్ వీఆర్ నాట్ యూస్డ్ ఎ మెయిల్ బట్ ఇట్ ఈస్ ఫుల్ ద రీజన్ బిహైండ్ దట్ ద సేమ్ మెయిల్ ఐడి ఈస్ గివెన్ ఫర్ ద సింకింగ్ ఆఫ్ యువర్ మొబైల్ అప్లికేషన్స్ మన మొబైల్లో వాడే డేటాకి 15 kg కాదు 15 GB కాదు 50 GB అయినా యూజ్ అయిపోతుంది మ్యాక్సిమం వాడతాం కదా మనం సో దట్ ఈస్ ద రీజన్ దే హ్యావ్ ఇన్స్ట్రక్టింగ్ దట్ యువర్ మెమరీ స్పేస్ ఈజ్ ఫుల్ then you purchase a separate memory otherwise normally we'll do that again we'll create a one more mail for syncing of the new data so that is the memory space in the cloud it is going to happen by using the layer framework for the cloud application development right and not don't consider this one we have one more topic as we discussed here no so this one there is a communication can be established between the distributed systems the communication or message can be transferred through IPC I told you IPC inter process communication so what is IPC now we have to discuss IPC and RPC we have to discuss with that we'll finish right so next topic write down inter process communication inter process communication like inter cricket college competition inter college cricket competition inter college chess competition that is the competition for the chess game among the inter colleges in sense the colleges which is located near to this one of same category inter engineering colleges not inter like intermediate inter colleges of same type all the engineering colleges located in the premises of Kakinada they have conducting a workshop that is inter college sports meet inter college chess competition అంటే they are involving who are the participants are the colleges the reason for participating to play chess inter process communication here we are communicating we are Inter-process. The processes are communicating with each other. The processes are competing with each other. ఇందాక ఏం చెప్పండి, డిస్ట్రిబ్యూటెడ్ కంప్యూటింగ్ వన్, డిస్ట్రిబ్యూటెడ్ కంప్యూటింగ్ టూ can be established a connection between the systems. In the distributed environment, system 1, system 2 can be communicated with the IPC. This IPC will help to the people who are in independent systems, independent users. Two users can be talk with each other by phone call, by WhatsApp call. That is called an intermediate. That is a once communication channel can be established between the two users and between the two processes. Process 1, process 2, process 3. In the individual distributed system law, processor 1 have its own memory, that is one box. Processor 2 its own memory, second box. Third, 4 and n. Processor n with the memory of separate box. This one is communicated with the second one upon arrow IPC. That IPC is a mechanism. See, in cloud computing, it refers to the technique or a mechanism that enables processes running on different virtual machines, containers, or cloud services to exchange data and coordinate execution over internet or execution over the internet. So here why we need to communicate the processor 1 with the processor 2 in distributed system? ఇందాక ఎందుకు ఇంకొకరి బ్యాగ్లో బుక్ పెట్టాల్సిన అవసరం ఏమొచ్చింది? Everyone have your own bags, but you are asking to someone else to keep these two notes in your bag. ఎందుకు? నీకు నీలాంటి నీకు సేమ్ లైక్ బ్యాగ్, యూ ఆల్సో హ్యావింగ్ ద సేమ్ బ్యాగ్, బట్ ద రీజన్ బిహైండ్ దట్ నీ బ్యాగ్ ఆల్రెడీ ఫుల్ అయిపోయింది బికాస్ యూ హ్యావ్ మోర్ నెంబర్ ఆఫ్ బుక్స్, అది ఫుల్ అయిపోయింది కాబట్టి స్పేస్ లేదు కాబట్టి వీఆర్ ఆస్కింగ్, వీఆర్ రిక్వెస్టింగ్ ఫర్ అదర్ యూజర్ బ్యాగ్ పెట్టు, ఆ బ్యాగ్లో ఈ రెండు బుక్స్ పెట్టుకోండి. దట్ మీన్స్ దట్ వీఆర్ ఎక్స్చేంజింగ్ సంథింగ్. ప్రాసెస్లో కూడా ప్రాసెస్ 1, ప్రాసెస్ 2, ప్రాసెస్ 3, వైల్ 2 ప్రాసెస్ ఈజ్ నథింగ్ బట్ సెట్ ఆఫ్ ఇన్స్ట్రక్షన్స్. ప్రాసెస్ అంటే ప్రోగ్రామ్ ఆ టాస్క్. ప్రాసెస్ని ఎగ్జిక్యూట్ చేసేది ప్రాసెసర్. Process is nothing but a job, program, task can be executed by the processor. That process to process, there may be a required some communication. That communication, reason behind that communication is they want to exchange some data, they want to exchange some resources. For that exchange of information and data and information can be done in the cloud computing by using a protocol or a technique called as IPC. IPC అనేది ఒక టెక్నిక్. ప్రాసెస్కి మధ్యలో ఒక కనెక్షన్ ఎస్టాబ్లిష్ చేసి వాళ్ళిద్దరు మాట్లాడుకోవాలి, ఏం కావాలి షేర్ చేసుకోవాలి. దట్ ఈస్ ఐపీసీ. ఇన్ క్లౌడ్ ఎన్విరాన్మెంట్ అప్లికేషన్స్ ఆర్ డిస్ట్రిబ్యూటెడ్, స్కేలబుల్ అండ్ ఆఫన్ లూజ్లీ కపుల్డ్. సో ఐపీసీ మెయిన్లీ రిలైస్ ఆన్ నెట్వర్క్ బేస్డ్ కమ్యూనికేషన్ రాదర్ దాన్ షేర్డ్ మెమరీ. క్లౌడ్లో ఏంటి, వాట్ ఈస్ ద మీనింగ్, యాక్చువల్ క్లౌడ్ మీనింగ్ ఏంటి? క్లౌడ్ కంటైన్ డిఫరెంట్ సర్వీసెస్ విట్ విల్ బి ప్రొవైడెడ్. దాంట్లో డేటాబేస్ ఉంటుంది, డిఫరెంట్ కైండ్ ఆఫ్ రెడీమేడ్ అప్లికేషన్స్ ఉంటాయి, రైట్? సో డిఫరెంట్ కైండ్ ఆఫ్ రీసోర్సెస్ అన్నీ ఉన్నాయి అక్కడ. ఆ రీసోర్సెస్ని డిస్ట్రిబ్యూటెడ్ మేనర్లో యూజ్ చేస్తుంది. దెన్ వీ కెన్ సే దట్ ఇన్ ద సింగిల్ వర్డ్ క్లౌడ్ ఈజ్ ఏ విచ్ ఈస్ డిస్ట్రిబ్యూటెడ్ మేనర్ ఇట్ ఈస్ వర్కింగ్. ద క్లౌడ్ విల్ వర్కింగ్ ఆన్ డిస్ట్రిబ్యూటెడ్ మేనర్. నీకు ఎవరికి ఏది కావాలన్నా ఇచ్చేస్తారు డిస్ట్రిబ్యూటెడ్. And distributed in sense, same type of resource can be used more number of users. Same memory space లో అందరికి ఇచ్చేస్తాం. That is distributed manner. So cloud can be working on a distributed manner, and IPC can also be IPC also distributed manner, and which is scalable, which is extendable, and also that it is loosely coupled. Loosely coupled in the sense it is not restricted for the strictly restricted for only limited space. We can add and delete. That is loosely coupled. So IPC is working with that machines of cloud on the basis of distributed environment only. By using distributed techniques, by using distributed concepts, IPC interprocess communication working on that. So memory shared లో IPC అవసరం లేదు. Shared memory MIMD, there IPC is not required. Distributed MIMD systems itself required IPC. So where distributed systems working on IPC, because of cloud also working same thing, అందుకే క్లౌడ్ కంప్యూటింగ్లో have a different kind of systems, SISD, SIMD and so on. And MIMD లో మళ్ళీ టూ కేటగిరీస్, షేర్డ్ మెమరీ అండ్ డిస్ట్రిబ్యూటెడ్. క్లౌడ్ అంటేనే డిస్ట్రిబ్యూటెడ్ కాబట్టి ఈ క్లౌడ్లోనే కమ్యూనికేషన్ ఎస్టాబ్లిష్ చేయడానికి వీఆర్ యూజింగ్ ఐపీసీ. Common IPC mechanism in cloud computing includes message queues, remote procedure call, and these are the different methods. RESTful and APIs, publish subscribe systems and sockets. Cloud computing lo communication established IPC. I told you no IPC. Not only IPC, RPC also there. Using remote procedure call only, we can communicate with each other. We can share the data over the cloud. In the same way, IPC and RPC, some other techniques also there. Just you remember the names. This RESTful and also that APIs. APIs, anyways, you are aware of that API. APIs can be provide a communication. Java APIs, Cloud APIs, .NET APIs. అవన్నీ ఏం ప్రొవైడ్ చేస్తాయి? జస్ట్ ఇట్ విల్ ప్రొవైడ్ అన్ ఇంటర్ఫేస్ టు యూజర్ టు దట్ పర్టికులర్ సాఫ్ట్వేర్. ఏ అప్లికేషన్ ప్రోగ్రామ్ ఇంటర్ఫేస్, ఏపీఐ అంటేనే అప్లికేషన్ ప్రోగ్రామ్ ఇంటర్ఫేస్. నువ్వు ఒక సాఫ్ట్వేర్ యూజ్ చేసినప్పుడు ఏపీఐ విల్ బీ ప్రొవైడెడ్ హౌ దట్ సాఫ్ట్వేర్ విల్ బీ యూస్ఫుల్. These mechanisms allow cloud services to communicate reliable across data centers while supporting fault tolerance and load balancing, elastic scaling. Scaling itself we can say elastic. So these above methods, IP, yes, IPC and RPC, RESTful APIs and so on can be useful for communication establishment in the cloud. For they will balance the load across the system, and also fault tolerance will be maintained. Fault tolerance in sense, if anything only one device, one part is failure, entire system will not get affected. Will not get affected. So that tolerance also, fault tolerance also will be maintained. Note down this IPC. So IPC is the most important, and most probably they will ask that explain about IPC in cloud computing. Note down the first 2 points at least. You can remember what is basic IPC. Phones పక్కన పెడితే లేకపోతే నాకు ఇచ్చాను మొబైల్స్. ఏనా ఏమైందమ్మా? ఇక్కడ పడిపోయిందా బయట పడిపోయిందా? ఇక్కడ క్లాస్లో పడిపోయిందా అక్కడ పడిపోయిందా? క్లాస్లో క్లాస్లోనే ఇచ్చిరా ఇచ్చి నువ్వు కూడా కాసేపు ఓదార్చి అట్లాంటిది ఆపించొద్దు అట్లా పడిపోయినప్పుడు. అది ఒక పాయిజన్, అది థమ్స్ అప్. సమ్ వాటర్ అట్లీస్ట్. Write down the first 2 points regarding inter-process communication. మీకు నిద్ర వస్తుందా? ఫీలింగ్ డ్రౌజీ. ఫస్ట్ టూ సరిపోతుంది అట్లీస్ట్. ఎస్ అండ్ లేప్. సో The next one. సిస్టంలో యూట్యూబ్లో ఒక సాంగ్ ప్లే చేయొచ్చు. నువ్వు ఇక్కడే ఉండి నీ సిస్టంలో ఉన్న వర్డ్ డాక్యుమెంట్ని యాక్సెస్ చేసుకోవచ్చు. దట్ ఈస్ వీ కెన్ కాల్ బై సెండింగ్ ఏ వన్ కాల్ ఇన్ఫర్మేషన్ to the remote system will run a program. Program is nothing but opening a video player. యూట్యూబ్లో వన్ సాంగ్ ప్లే చేయడం is one program. That can be done in the remote system by using a RPC method it is involving. That remote program call. So remotely there is a program which we are calling by sending one information. But how this information is passing by through networks only. But how connection is established, we least bothered. Then in RPC, the client send a request to the remote server. Client is sending the request to the remote server containing the procedure name and parameters. ఎప్పుడైతే నువ్వు ఆర్పీసీలో యూజ్ చేసి కమ్యూనికేషన్ ఎస్టాబ్లిష్ చేయాలనుకుంటున్నావో, ఇక్కడ ఉన్న నీ సిస్టంలో నుంచి సమ్వేర్ ఎల్స్ ఒక సిస్టంలోకి ఫస్ట్ యూ హ్యావ్ టు సెండ్ వన్ రిక్వెస్ట్. సెండింగ్ ఎ రిక్వెస్ట్ టు ద రిమోట్ సర్వర్. ఇక్కడ నుంచి ఆ రిమోట్ సర్వర్కి ఒక మెసేజ్ పాసింగ్. త్రూ దట్ మెసేజ్ ప్రొసీజర్ ఏంటి, ఆ మెసేజ్ contain the procedure name and parameters. అండ్ ఆ మెసేజ్లో ఏముండాలి, ఆ రిక్వెస్ట్ మెసేజ్లో ఏముండాలి, వాట్ యూ వాంట్ టు డూ, that is called parameter list, and also that procedure name, what you want to do on that remote system. The server execute that procedure and send the result back to the client. So what do you want, you have mentioned in this program procedure name and parameters, and that will be executed at that outside of the program, outside of the remote location. So that will be executed at other end, and the result will be given to the actual client and server. అక్కడ ఏం జరిగిందో మళ్ళీ క్లయింట్కి ఇన్ఫర్మేషన్ ఇస్తుంది, రిజల్ట్ బ్యాక్ టు ద క్లయింట్. దిస్ కమ్యూనికేషన్ ఈజ్ హ్యాండిల్డ్ త్రూ ద నెట్వర్క్ ప్రోటోకాల్స్. డెఫినెట్లీ ద communication protocols are the TCP UDP protocols only. By using TCP and UDP protocols only, the communication can take place. The information or data can be transferred from one location to another location by using a packets. Each packet contains information from one location to another remote system. That can be established that packets are sending through the normally TCP and UDP protocols. Most of the cases UDP protocols we are using. User datagram protocols. సో టీసీపీ ప్రోటోకాల్ ఎందుకు యూస్ చేస్తాం? సిఎన్ అయిపోయిందా? సిఎన్ ఉందా మీకు? కంప్యూటర్ నెట్వర్క్స్ అయిపోయిందా? దెర్ ఈస్ టీసీపీ యూటీపీ ప్రోటోకాల్స్ ఇన్ ద లేయర్స్ ఆఫ్ ద ఓఎస్ఐ మోడల్. TCP protocol is used for only the communication can be interactive communication. Like once you are sending a request, you are expecting a response. Request and response we are using TCP IP. And a request and response lo communication can take place as a, it is authentication. నువ్వు హాయ్ అని చెప్తే అక్కడ నుంచి రెస్పాన్స్ రావాలి, మళ్ళీ నువ్వు సంథింగ్ చెప్తే అక్కడ నుంచి రెస్పాండ్ అవ్వాలి. అప్పుడు వీ కెన్ హ్యావ్ ఎ ట్రస్ట్ ఆన్ దట్ నెట్వర్క్ దట్ ఎస్ నేను అనుకున్న అవతల ఉన్న పర్సన్ నాతో చాట్ చేస్తున్నాం. ఇఫ్ యూఆర్ కీప్ ఆన్ సెండింగ్ ఏ మెసేజ్ దట్ రిప్లై ఇస్ నాట్ రెస్పాండింగ్ ఫ్రమ్ ద అదర్ సైడ్, ఈవెన్ దో ఈజ్ రీడింగ్ బట్ రెస్పాన్స్ ఈజ్ నాట్ రిసీవ్డ్, దెన్ దెర్ ఈజ్ అన్ డైలమా. అంతేనా? మన వాట్సాప్లో మెసేజ్ చేసేటప్పుడు ఇమీడియట్ రెస్పాన్స్ రావాలి, బ్లూటిక్ రావాలి, మళ్ళీ ఇమీడియట్గా ఒక మెసేజ్ కూడా రావాలి. బ్లూటిక్కే వచ్చింది అనుకోండి, మళ్ళీ ఒక మెసేజ్, మళ్ళీ ఒక మెసేజ్, అన్నిటికీ బ్లూటిక్ వచ్చింది, రెస్పాన్స్ రాలేదనుకో, అప్పుడు మనకి డౌట్ వస్తుంది. మళ్ళీ చూసేది వాడైనా కదా, అవునా? మొబైల్ ఓనర్ అయినా కదా చూసేది. ఇఫ్ మొబైల్ ఓనర్ అయితే మా ఫ్రెండే కాబట్టి రెస్పాండ్ ఇస్తాడు. రెస్పాన్స్ ఇవ్వట్లేదు అంటే మెసేజెస్ లీక్ అయిపోయినాయి, బట్ ఈజ్ నాట్ రెస్పాండింగ్. సో సంథింగ్ వెంట్ రాంగ్. So that is the one way of communication done with the UDP protocols. And whenever you are expecting a interaction systems, request and response, for this type of communication we are using TCP protocols, in RPC also. So sometimes in RPC itself uses UDP protocols. Using UDP protocol also communication can be established. ఇక్కడ ఏంటి, just will send a packet of information, set of packets as an information can be sending to the server or end user, and least bother అది పోయిందా లేదా మనకు సంబంధం లేదు. దట్ ఈస్ ద లీస్ట్ బదర్, అది పోయిందా లేదా సంబంధం లేదు. అలాంటి వాటిలో యూడిపి ప్రోటోకాల్స్ యూస్ చేస్తాం. సో ద డిఫరెన్స్ ఈస్ యూడిపి అండ్ టీసీపీ ఈస్ లైక్ దట్. Both the network protocols can be used over here, depends upon the situation, depends upon the communication you want to establish. So that is about RPC, remote procedure call. These two are the distributed computing. In the distributed MIMD, the communication can be established through the IPC. IPC, we used RPC. RPC is a one type of IPC mechanism. See, remote procedure call is an inter-process communication mechanism, right? So these are the advantages of the remote procedure call. Easy to use. It's look like local call, and also structured and efficient. language and platform independent. Language and platform independent. నువ్వు యాపిల్ ఫోన్ యూజ్ చేసినా అవతల వాడు సామ్సంగ్ ఆండ్రాయిడ్ ఫోన్ యూజ్ చేసినా we can establish a connection and we can talk each other, we can chat each other by using an app called as Instagram or whatever it is, social media. We can communicate it, which is platform independent. నీ దాంట్లో ఆండ్రాయిడ్ ఉంటే అవతల ఆండ్రాయిడ్ ఉన్న వాళ్ళకి కమ్యూనికేట్ కావాలి. Have a different ways also we can communicate it. But the communication can be established by using RPC. RPC workout or establish a connection by using the network protocols only. Most of the cases interactive TCP, otherwise it is UDP. So advantages: easy to use and structured and efficient, language and platform independent. The limitations are network failure affect execution, higher latency than local calls. So there is some problem also. Network failure effects. If the outside user doesn't have an internet connection properly, definitely he will not respond immediately. The response will get delayed. అప్పుడు మనం ఏమనుకుంటాం మెసేజ్ పోయింది ఇంకా రెస్పాన్స్ రాలే దెన్ వేర్ ఇన్ సమ్ లిటిల్ బిట్ ఆఫ్ హరీ అండ్ ఎగ్జైట్మెంట్ ఇంకా మెసేజ్ రాలేదు అని మెసేజ్ చేసిన 1 minute మెసేజ్ చేసిన 50 seconds అయిపోయింది ఇంకా రాలే ద రీజన్ బిహైండ్ దట్ మనకు 2 ticks వస్తాయి బట్ మెసేజ్ ఈజ్ నాట్ రిసీవ్డ్ ఎట్ అదర్ ఎండ్. When he called to that person also, sometimes he said, no, I didn't receive any messages. We told you that, yes, I sent a message long back, 1 minute back, 2 minutes back. But still he has not received due to the failure of network. That may happen that in the remote procedure call. Their remote procedure call RPC established a connection, but the connection may be lost because of the reason network connection is unavailability. So I told you that communication with the cloud, communication with the remote processor, communication with the IPC of the remote system can be established always through the internet only. Once the network connection is failure, we cannot able to communicate with the servers or other systems which is far away. Even though in the cloud environment, different services are provided. అందులో మెమరీ ఉంది సర్వర్స్ ఉన్నాయి అన్నీ ఉన్నాయి కనెక్షన్ వస్తుంది రిజల్ట్ అనుకోండి సర్వర్ విల్ బి లోడెడ్ and whenever the connection is interrupted, internet is interrupted, we cannot able to load that particular page sometimes. Sometimes from online you are loading something, so page 1 2 3 4 loaded, page 4 still it is not able to load because of connection interruption. Movie rules lo movie చూసినప్పుడు sometimes it is interrupting, that it is buffering. Reason behind that buffering is that there may be a something went wrong, that is disconnected. The RPC is not properly provided, IPC is not provided between the movie rule server to our desktop. There is an internet connection. Higher latency than local calls. Latency is nothing but delay. So definitely, if something went wrong, that is delay, that network connection is fault, then receiving and sending a messages is delayed. That highly delay can be happened. Those are the different limitations or we can say challenges. The last topic about according to your syllabus, service oriented architecture. Service oriented architecture, write down next one. Service oriented architecture, write down. SOA is an architectural approach. SOA is an architectural approach in which applications SOA is an architectural application in which applications make use of services. Applications make use of services available in the network. Make use of services available in the network. make use of services available in the network. So this SOE is useful to build a grid computing or grids in a cloud computing for the cloud builds and the grid of clouds. So grid of clouds is normally grid computing. What is grid computing? Yesterday we discussed cloud computing, grid computing. Grid computing is nothing but computation can be takes place between the set of distributed systems. Every system will act as an independent system. Their own infrastructure is there, and among the set of independent systems, will have an establishment of connection to share the resources as a grid. Cluster computing, set of clusters called as grid. Cluster computing lo and grid computing నేర్చుకున్నాం. Grids of clouds అంటే cloud itself having a set of services. Cloud 1, there are 3 services. Cloud 2, 4 services. Cloud 3, 10 services. Between these combining as a one unit, this one cloud 1, 2, 3 is collectively working for the one task as a single server, as a single cloud called as grid. Grid అంటే వీళ్ళు ముగ్గురు కలిసి ఒక పర్పస్ కోసం వర్క్ చేయడం. As a team, we are calling a team. A team behind number of users, number of students. This project is done by the team 1. The team 1 contain only not only the one user, one student. The set of students are collectively working towards the project. Then that project has been successfully executed. So grid of cloud is nothing but different collection of services, and such a different collection of services combined as a grid of clouds. See, this SOE is a software design approach. Conceptually, collection of services or network that communicate with one another. So whatever the services we have provided, all those services can be collectively combined, collection of services and network that communicate with each another. So there are different services we have, and each services, between those services we have to establish a connection. Then we have a software called as SOA. What is SOA? Service oriented architecture. The service oriented architecture provides different kind of services. SOA provide different kind of services. And the conceptually collection of services and network that communication with one another. So SOA itself contain different services. That's what it is, a collection of services collectively combined as a one unit to provide the different kind of services to the user with that single application SOA. SOA are loosely coupled. When it is loosely coupled, means that we can extend it. Whenever it is tightly coupled and loosely coupled difference, the blind difference is that tightly coupled cannot be altered. Tightly coupled cannot be altered. Loosely coupled can alter, can delete and add something into that. So in the service oriented architecture, if initially 10 services as one single unit, no go app చేస్తాం యాప్లో 10 services ఉంటాయి. Service 1, you can see your attendance. Service 2, you can see your internal marks. Service 2, in the same app, you are provided to see previous external end exam marks if it is released. And one more service it is there, leave application also there. Whenever you wish to absent for the college, you can apply leave on that. That service also there. And you are provided in the same app one more service, fee payment service, semester fee payment service, as well as tuition fee also paid through that service. So different kind of services collectively gathered and placed into one unit, as we can say service oriented architecture can be possible as a one system. So that app named as so and so KIET student app. What KIET student app will be provided? These are the services mentioned. So SY is higher level application development. SY typically leverages some standards based on integration. So it will maintain leverages and standards. Based on the standards, it will have a different kind of privacy. So if you're if you are providing an app, to the local application, in the local system only it is using, then no need of more security. We are not connecting internet. So if it is an you can use this app at anywhere from this internet. Definitely should provide privacy and security by providing security protocols and security mechanisms. The key player includes the service provider and service consumer. No app just no Kite student app is the who will use that, not developer. Developer just develop an app called as Kite student app. But who is the key users? Key users are the Kite management, that is administrative people, as well as the students of Kite. These are the main key players like service providers and service consumers. Service providers are the Kite user, Kite administration, and service consumers are the students. If it is an app called as Kite student app, so whenever service consumer like student is requesting, I want to see my internal marks, then it is asking that some prompt it is asking, as student enter your student roll number. So I want to pay some tuition fees. Then it is asking that enter which semester fees you want to pay. So I want to pay that semester, third semester, fourth semester fee. Then it displays that value. I want to pay, so to pay my project fees. Which project? Mini project, minor project, major project. So such that it is asking. So whenever you are requesting such that, it is asking that which semester. Then again third semester you entered. Then it is responding. It shows that his third semester tuition fees total due is this much of. Then accordingly you will react it. See here how it is SOE is coming into the picture. Before SOE, అన్ని అప్లికేషన్స్ ఒకదాని లేకుంటుంటాము. There is monolithic. Monolithic is single app. If the app is XYZ app is used, that is useful for only to check your attendance. In that app, we cannot able to see your results. For that results, there is one more app. And later, for example, see, assume that initially we have app for separate app for the checking the attendance, and one more app existing for the results of internal marks and external marks. One more app to pay the tuition fees and so on. Likewise, different kind of operation, different kind of applications. That is monolithic is it is specially designed for the specific purpose. When two tier, when two tier is a little bit more favorable than uniprocessor like. It is uniprocessor monolithic, now it is two tier. So multi-purpose, but not more than two or three or five, just little combinations. Then in entire applications, in number of applications can be collected together, but there may be a disadvantage and more user friendly. ఇంతకుముందు కూడా సేమ్ ఒక వెబ్సైట్లో different kind of services ఉండొచ్చు. Instead of using website, users are more friendly with the applications. SBI Bank is online sbi.net వెళ్ళాలి, username password enter చేయాలి every time. You have to remember that username password, and later you have to go for the transactions or deposits, whatever it is your profile, check that details. There also different kind of services will be provided like entire, but nowadays it is in your hand. SBI app, Yono app is there. On one click, Yono app, no need to remember the password. Once it is entered, it will be saved and opened. And whenever you done a transaction, that time also it is asking the profile password or PIN number. It is not here password. We can say PIN number. Just 4 digits or 6 digit PIN number is enough to remember to do the transactions. It is more familiar than this website access. So that is called this SOA. See here the procedure oriented, object oriented, next component oriented, service oriented. So initially procedure oriented is nothing but initial system. The procedure which is what is there in the procedure can be specified in a one place. Later on it is converting into the object oriented. Object oriented can be defined within a abstract manner. And a complete details ఏముండవు, just abstract manner we are using. Object manner it is converting into the component oriented. Component oriented is instead of having an instructions in abstractly, we have a small devices components we have. అక్కడి నుంచి పోయి ఏమొచ్చింది ఇప్పుడు నెక్స్ట్ ఇట్ ఈస్ సర్వీస్ ఓరియంటెడ్ ఆర్కిటెక్చర్. ది సర్వీస్ ఓరియంటెడ్ ఆర్కిటెక్చర్ విల్ హ్యావ్ ఏ వన్ యాప్ మెనీ many services will be provided. అంటారు కదా జనరల్ వన్ యాప్ కెన్ సర్వ్ డిఫరెంట్ కైండ్ ఆఫ్ అప్లికేషన్స్. ఐ థింక్ దిస్ ఇస్ ద లాస్ట్ వన్. ఓకే. And note on this architecture of the SOA, it is not like architecture, just how it is communication. See here, service brokers and service consumer, service provider. Whoever the provider of services can interact with the service consumer, clients. Client can find service brokers, right? And here brokers are having different kind of services. See here, this is the general structure of the SOA. అమెజాన్ యాప్లో ఓపెన్ చేసి సో అండ్ సో ఐటమ్ కావాలంటే అమెజాన్ ఇట్ సెల్ఫ్ డజంట్ హ్యావ్ ఎనీ ఐటమ్ షాప్. అమెజాన్లో వాచ్ షాప్ ఉండదు, అమెజాన్లో ఫ్రిడ్జ్ షాప్ ఉండదు. అమెజాన్ విల్ ప్రొవైడ్ అండ్ దే విల్ హ్యావ్ ఎన్ ఏ కాంటాక్ట్ విత్ ద రెస్పెక్టివ్ కన్స్యూమర్ గుడ్స్. వాచ్ అంటే సో అండ్ సో వాచ్ కంపెనీతో లింక్ ఉంటుంది కాబట్టి దే విల్ ప్రొవైడ్ అన్ యాక్చువల్ ఐటమ్. సర్వీస్ ప్రొవైడర్స్, క్లయింట్ అండ్ సర్వీస్ ప్రొవైడర్ దే విల్ ఇంటరాక్ట్. Service brokers are like your LG washing machine as service brokers, IFB washing machine service brokers, right? So Hitachi AC service brokers. Service brokers are who will provide actual item to the service providers. But it's look like the communication can be established between the client and service providers. We will generally we cannot communicate with these service brokers. We'll communicate with the service providers only. Service providers will give the information regarding which type of items are available. That information can be maintained by the service brokers. We will find details of the product by using service brokers. And but we'll pay the amount and we'll give the request, give an order to the service providers only, Amazon providers only. Amazon is responsible to take care about the particular order item. Wherever it is, it will brought. It will brought. Predefined service brokers are there. They will provide it. సో మనకి ఇదంతా అవసరం లేదు. అమెజాన్ ఒక యాప్ ఉంటుంది, క్లిక్ చేస్తాం, సెర్చ్ అన్ ఐటమ్ సో అండ్ సో వాచ్, ఆర్డర్డ్, పే అమౌంట్. ఆ వాచ్ ఎక్కడి నుంచి వస్తుందో మనకు సంబంధం లేదు. ఈ వాచ్ అన్నీ అమెజాన్ దగ్గర ఉండవు. ఈ వాచ్లు నీకు కావాల్సిన ఎవ్రీ ఐటమ్, బాటిల్స్, క్లిప్స్, makeup kit, they don't have a separate shop Amazon. They have a link for the corresponding consumable goods called as service brokers. So these are the basic components of SOA consist of service providers, service consumer and service regulatory. So he will publish the system, he will publish the product details to the service provider. I have so and so watch, the details are so and so, he will publish to the service provider. Service provider will give the same description about the item to the client. Based on the description of the item, once you like it, then you order it. And you will get the order from the service broker only. Okay, na? So this is about basic components. So this is the last topic, service oriented architecture of the unit 2, right? From this, I'll close this session. Thank you. Thank you for cooperating since